So doing this problem here in bell work, it looks a little bit complicated, but nothing hard. Cosine of 30 degrees. If I'm doing cosine of 30 degrees, you hold up your hand, 30 degrees. What's cosine going to get me? Radical 3 over 2. Good answer. Thank you for all repeating it at once. Radical 3 over 2. Grant, what's cosine at 60 degrees going to get me? 1/2. Sine at 30 degrees. Carrington, what's sine at 30 degrees going to get me? 1/2. And then Ashley, sine at 60 degrees? Square root of 3 over 2. Okay, so I have square root of 3 over 2 times 1/2 minus 1/2 times square root of 3 over 2. What's that going to get me in the end? That gets me 0. Okay, cool. 0. This one, same concept. Sine of 120, cosine of 30. So sine of 120. Mara, what's sine of 120 going to get me? Radical 3 over 2. And it's positive even though it's in the second quadrant because it's the y value. Aisha, what about cosine of 30? Radical 3 over 2. Minus, Allison, what's cosine of 120 going to get me? Negative 1/2. Garrett, what about sine at 30? 1/2. So I'm putting this together. Radical 3/2 times radical 3/2 would be 3/4 because the radical 3's would get you 3, and 2 times 2 gets me 4. Then it's going to be plus sign here because I have 2 negatives in that second part. I've got minus and a negative. So minus a negative gets me plus. 1/2 times 1/2 gets me 1/4. And when I add those together, it gets me 1. Okay? It gets me 1. It seems real basic. It's not doing a ton. Look at these formulas real quick. I made it. Look at these formulas. Okay? I'll pass you out a paper here in a second. Look at those formulas. These are true statements. Apply what you're seeing up there to those. Try to figure out which formula does that thing work with. Sum and difference identities. It's on the paper I'm handing out to them. So as we look at these sum and difference identities, you see the ones that are up here. We've got, it goes cosine times cosine minus sine times sine. Here are those sum and difference identities right here. Which one of those patterns does it match up with? 2, right? Cosine, cosine minus sine, sine. See how it's the same thing as this right here? Cosine, cosine minus sine, sine. So it is the same thing as cosine of alpha plus beta. What do you think my alpha is in this problem? 30. Whatever number comes first, that's my alpha. So it's cosine of 30 plus 60. What's 30 plus 60? 90. What is cosine at 90 degrees? That guy is 0. Okay? That's exactly what we got on it originally. They work both ways. You could split it up and do it that way, or you could do it the other way. Okay? Same thing down below. Sine of 120, cosine of 30. Let's look at our sum and difference identities, see which ones it matches with. Oops. You get the idea. Sine, cosine minus cosine, sine. Which number up here does it match with? 4. Number 4, it says sine of alpha minus beta. Sine, cosine minus cosine, sine. Okay? So this is the same as sine alpha minus beta. My alpha is 120. My beta is 30. 120 minus 30 is 90. What's sine at 90 degrees? Hey, it's 1. Exactly like what we got here initially. Sum and difference identities, they work. Okay? It's a new thing I'm going to give you today. Okay? It's different than what we did in the last chapter. I'm not going to ask you to memorize them. I could, but I also think there's like a maximum amount of things you can memorize, and this is not the most important ever. If you wanted it, you Google it on your phone, and you look up sum and difference identities. Okay? Are we good with that? Put your name on Bellwork. Pass it up for me. All right, so using those sum and difference identities, we are going to find the exact value of cosine of negative 15 degrees. Is cosine of negative 15 degrees on your unit circle? No. If you look at this guy, we don't go to 15 degrees. That's not a thing. Okay? So 15 degrees doesn't work. We are going to find the exact value, though. So exact value means I can't use my calculator. So instead, I'm going to start off by building 15 degrees, negative 15 degrees, using stuff that we know. All right? So I'm going to use sum and difference, adding and subtracting to get negative 15. What numbers on this unit circle of things that we know could we use to get negative 15 degrees? 30 minus 45. Anything else? 45 minus 60. 135 or 120 minus 135. There's a bunch of different things. Okay, this is an endless list. It can go on forever. It doesn't matter which one you pick. You pick one. Okay, we started with 30 minus 45, so let's do that. It's cosine, so I'm going to use the identity that goes with cosine of 30 minus 45. Okay, so we're going to use the sum and difference identity that matches that. We decided it's a cosine problem, and I subtracted two angles. So guess which formula I'm going to use? Number 5, the one that was cosine that I subtracted two angles. So that's the formula I'm using here. Cosine alpha, cosine beta, minus sine alpha, sine beta. I'm going to plug in alpha and beta. So it's cosine of 30 times cosine of 45. With cosine, the formula has a plus sign in between when we subtract. Plus sine of 30, sine of 45. Plug in and solve it. Think about unit circle. Do those values, plug it in, and try to simplify. See what we did. Cosine of 30, that is radical 3 over 2. Cosine of 45 is radical 2 over 2. Plus sine of 30 is 1/2. Sine of 45 is radical 2 over 2. Okay? When we're multiplying these, we multiply straight across when we're multiplying fractions, so the bottom's 4. What do I get when I take radical 3 times radical 2? Radical 6. You just straight multiply the radicals. 3 times 2 is 6. Okay? Plus, over here, this is a 4 on bottom. 1 times radical 2 is radical 2. We do want to put this into one fraction. Okay? Since I have common denominators, and if you do this right, you'll always have common denominators, it's going to be here, a denominator of 4. What do you get when you take radical 6 plus radical 2? Radical 6 plus radical 2. You cannot combine those two things. You cannot add radicals. So it is radical 6 plus radical 2. Oh, that's a 2, not a 6. Done. That's it. That's as simplified as we're getting. Okay? That is the exact value. All right? We could have, on our unit circle, made an extra tick mark here at negative 15 degrees and labeled that. Okay? We just don't need to. We can find it using our sum and difference identities. Okay? It's not as common, but you could find it if you needed it. Our answers to these questions will look similar when we do these. Questions on the first one? Let's go to the next one. Sine of 13 pi over 12. Same concept. We're going to build that angle. You got to build 13 pi over 12, which is not the most fun. Thoughts on what we could do to find that? Yeah, that's about what I felt like it should be. Where's 13 pi over 12 going to be? Which quadrant? Third quadrant, because it's a little bit bigger than 1 pi, right? 12 out of 12 would be 1 pi. Here would be my suggestion. Convert this thing to degrees. And so my last class remembered the fact that if you take 13 over 12 and you multiply that by 180, that will throw it into degrees. Okay, technically it's over pi and you divide by pi, but those pi's are going to cancel. So if you take 13 over 12 times 180, that'll get you your answer. The answer is 195 degrees. Here's the other way you can tell. If you, look at this, look up here. If I put a hash mark in between 0 and 30 degrees, you are now splitting into twelfths. So this is 1/12. This is 2/12, which is 1/6, 3/12, 4/12, 5/12 right here. 6, 7/12, 8, 9, 10, 11/12, 13/12 is right here. Okay, they are 15-degree chunks. So if it's 13/12, it's 15 degrees more than 180. Okay, so if it's 7 pi over 12, it's 15 degrees more than 90. That's 105 right here. Okay, so kind of understanding where those fall in the unit circle will help you. 195, do that. Come up with two angles to get you 195. Use a sum and difference identity and try to solve that. Try that on your own. So looking at this, Amanda gave us 150 and 45. It's sine, and to get them, I had to add. We could have technically found two that subtracted to get there, but I did adding. And so now I'm using the sine formula. Sine of 150, cosine of 45, plus cosine of 150, sine of 45, and I'm plugging in. Sine of 150 is 1/2. Radical 2 over 2, plus cosine of 150 is negative radical 3 over 2. Radical 2 over 2. Radical 2 over 4 minus radical 6 over 4. I put those together. I get radical 2 minus radical 6 all over 4. Did somebody pick different numbers? Did you get the same thing? Yeah, you might have had a negative radical 6 first plus radical 2, but it doesn't matter. Every answer you get in these problems are going to be the same. When we do sine and cosine, it's always got a radical 6. It's always got a radical 2. It's always got a 4. The only thing is which one's positive, which one's negative. They could both be positive. One could be negative. They both could be negative. Just matters where you fall in the circle. Questions with that? Yes, sir. Yeah, if you did 45 plus 150, that's fine because you're adding. Adding doesn't matter. If we were subtracting, then it matters. Okay, so be careful. Make sure. Nope. It's just whatever I write down first. Doesn't matter. I wrote 150 plus 45. If I would have done sine of 45 plus 150, it would have given me the same answer. I was adding here because I was trying to get 195. Yes, you would want. Well, you would want to get, if you were trying to get 105, you would have to take 150 minus. Yeah, you're good. Okay. Let's look at the last one here. Tangent of 5 pi over 12. This one's a little uglier, and there's a little bit of a key to this. 5 pi over 12. Let's put that in degrees first because I don't like it. Which quadrant is 5 pi over 12 going to be? First quadrant. It's a little bit. It's a 12, so it's 15 degrees less than 90, right? Because 6 pi over 12 would be 90 degrees. I'm going back 1/12, so I'm subtracting 15 degrees. It's the same thing as 75 degrees. Find 75 degrees. What numbers did we use for 75 degrees? Don't pick this one. You totally can pick 30 plus 45, okay? But we don't want to pick 30 plus 45, and let's look at why. Yeah, I'm good. It was tangent of 30. Here's why you don't want to pick 30 plus 45. Look at the unit circle. Do tangent of 30 degrees. What is tangent of 30 degrees going to get you? 1 over square root of 3, which we don't like, which you would make radical 3 over 3, which, no, don't do that. You want to avoid that because it's going to make your life harder. That's going to happen at 30 degrees. You'll get radical 3 over 3. You'll also get that at 150. You'll also get that at 210. You'll also get that at 330. Okay? So we want to avoid the tangent that would get you radical 3 over 3. Find another way of getting 75 degrees that would avoid those values. $120 minus 45, I'm hearing. That gets me 75. What is tangent going to be at 120 degrees? Just negative radical 3. Just negative square root of 3. A lot easier to deal with. You can do it the other way, but you'll hate me more. And so I'd rather you avoid them. That way that the disgust doesn't grow. Okay? So avoid 30, 150, 210, and 330. And work with that. So tangent of those two numbers. Use your tangent formula of subtraction. Plug them in. Start to work. So we plugged into our sum and difference identity. It was tangent of subtraction. So there's our formula with numbers plugged in. Tangent of 120 degrees. That would get me negative radical 3. Minus tangent of 45 is 1. All over 1. Tangent of 120, again, is negative radical 3. Times tangent of 45 is 1. So this is minus radical 3. Okay, this is the numerical answer, but we can't leave our answer like that because I have a radical in my denominator. Okay, before we got rid of the radical in the denominator by multiplying the bottom by radical 3. Does that get rid of my radical in the denominator? No, it would get rid of one of them because that radical 3 times radical 3 would get you 3, but the other one, it would mess you up. Okay, so instead, what we're going to do is something we just did with sum and difference, or with our other identities. To get rid of that radical in the bottom, we are going to multiply by the conjugate. Okay, we just care about the denominator. I don't care about the numerator. The denominator is 1 minus radical 3. What is the conjugate of 1 minus radical 3 going to be? 1 plus radical 3. If I multiply it on bottom by 1 plus radical 3, I got to multiply the top by 1 plus radical 3. I'm going to have to do some foiling. I'm going to have to distribute this guy out. So that to that, that to that. So on bottom, I'm getting 1 plus radical 3 minus radical 3 minus radical 3 squared. On top, I would get negative radical 3 minus radical 3 squared minus 1 minus radical 3. Simplified top and bottom, see what you get. Show me with your fingers, what do we end up with here on bottom? Show me with your fingers, what do you end up with? A 2, and it looks like negative 2 of some sort. Let's talk about why. These two things, what's going to happen with the radical 3's? They cancel. So this is 1 minus radical 3 squared. Radical 3 squared is going to get me just 3. 1 minus 3, my denominator is negative 2. On top, not the same. Okay, this is the same. Negative radical 3 squared, that is negative 3 minus 1. That gets me negative 4. What about 1 negative radical 3 minus a radical 3? That is negative 2 radical 3's. If you had an apple and you took it away, you're minus 1 apple. And then if you take away another apple, that's minus 2 apples. Same thing here. You take away 1 radical 3, you take away another one, it's minus 2 radical 3's. All of those things can be divisible by 2, so we can divide everything by negative 2 in this case. Negative 4 divided by negative 2, we divide those two. That's going to get me 2. And then I can divide these two. That's going to get me positive square root of 3. Every time we do tangent problems, just like sine and cosine, we're always the radical 2 plus radical 6 stuff. Every time we do tangent, it's going to get you 2 and radical 3. It's just which one's positive, which one's negative. Just a matter of getting to that point. Questions with that guy? Not the most fun problem in the world, but you can handle it too. All right, let's look down below. A lot easier. The rest of the day's lesson will take no time, and you'll do great at it. The next two, 4 and 5, are just like bell work. They're already set up. You're doing exact value. You do not know what the cosine of 40 degrees is, okay? But hopefully you're noticing a pattern here. Cosine, cosine, minus sine, sine. Find the sum and difference identity that matches that pattern, plug in your numbers, and do it. Getting a lot of negative 1/2. It's cosine, cosine, minus sine, sine. So you're looking at your sum and difference identities. It is a cosine problem. The minus means I'm really adding them. Which one's my alpha? Whatever one comes first, so it's just 40. Beta is 80, so it's really cosine of 120. You go to your unit circle, you do cosine of 120. That is negative 1/2. Do the tangent problem. And when we plug in here, it is tangent of 170 minus 50, so it's tangent of 120, second quadrant. So you know it's negative, and it's going to be negative radical 3. Questions with that? Last problem of the day. Use sum and difference identities to prove the following identities. So we are establishing the identity. We're showing that this is true. Cosine of pi over 2 minus theta. You can plug in any theta in the entire world. Negative 9,000 degrees, 100.72 radians, it doesn't matter. Okay? It's going to be equal to sine of that same number. Okay? When you look at this problem and you see cosine with adding and subtracting, guess what we're going to use? We added or subtracted, perhaps like sum and differences. What do you think we should use? Oh, the sum and difference identities. Thank you, guys. I appreciate you being so focused and loving what I do. It's cosine and subtracting. And so I'm going to plug in the formula. I'm doing the cosine subtraction formula. Cosine of pi over 2 times cosine of theta minus sine of pi over 2 sine of theta. I'm using my sum and difference identities from up above. And that needs to all be equal to sine. Simplify that, guy. See what you get. Okay, so it is a plus sign in the middle. We're setting this up. Cosine at pi over 2. What is cosine at pi over 2 going to get me? 0 times whatever. It doesn't matter what cosine of theta is because it's 0 times that. So it's going to get me 0. Sine at pi over 2 is 1 times sine of theta. Means it's 0 plus sine of theta, which guess what? Is equal to sine of theta. I got both sides equal to each other. QED, I'm done. Okay, same thing on the right one. Sine, and I'm subtracting, so I'm doing sine of pi over 2 cosine theta minus cosine pi over 2 sine of theta. I'm using my sum and difference identities. I'm trying to get this whole thing equal to cosine. So when I do that, this is 1 times cosine minus 0 times sine. That guy doesn't matter. Cosine of theta equals cosine of theta. Yay for me. Tombstone. I'm going to make that into a Pac-Man ghost. Pac-Man ghost. I can do that. That's my job. Questions on something we did there?